Hello everyone. So let's start with another problem which is known as two sum. So here we are given an array of integer nums and an integer target, and we have to return indices of two numbers such that they add up and make a target. Okay, we can assume that each input array would contain only one solution, which that means add up two numbers and gives us the target. That could be only one possibility for that. So let's think about the approach. Okay. There could be a two-pointer approach if the array is sorted. Okay. And if the array is not sorted, then what we can do? We can use a data structure to take one number and then create a complement, or fetch a complement of another number if it is present in that data structure or not, something like that. Okay, so that's what is today my approach. I'll be using a data structure hash map to store the number and its complement and check whether the complement is present in the hash map or not. Okay, so let's take the example of like nums equals to 2, 7, 11, 15, and target is equals to 9. I have taken a hash map and I'll be storing each and every number until and unless I get a number and a complement of it. What I mean by complement? Complement means target minus nums of I, such that if we add the complement and nums of I, it becomes equals to target. Got it? So here, as we can see on the index 0 and 1, we are getting 2 and 7, and if we add these, we'll get 9. Correct? So that's how we'll solve our approach. So what we'll do, and you can see now the array given to us is not necessary to be sorted. So that's why we are not using two pointer approach. Okay, we are using a hash map approach or a new data structure approach. So what could be our logic? Let's take a hash map containing integer and integer, key as the number and value as the index of that particular number in the array. And we can take an array of size 2 to store the answer, and answer contains the indexes of those two numbers, which when added gives us the target value. So let's now implement it. Let's take length of nums in L. Let's take an array of size 2. Let's take hash map to store the number and then check for the complement of that number using the for loop. So what could be a condition in the for loop? That first we'll calculate the complement, that is target minus nums of I. So if map dot contains key complement, then we can make answer of 0 is equals to map.get complement within the bracket and answer of 1 is equals to I, and at last we can return answer. Otherwise, if the complement is not present, to remember it, we store it into the map. So map.put nums of I with the index I as key and value pair. At last, if nothing is present, that makes target. So then we'll return the answer. Let's try to run it. Complement C is small. Let's try to run it again. I have taken air. Let's make it answer. Now it will work exactly fine. There was some syntactical error. As you can see, target is 9, 2 plus 7 is equals to 9. So 0 and 1 position. 6, 4 plus 2 is equals to 6. So 1 and 2 is the position. And 3 plus 3 is equals to 6. So 0 and 1 is the position. Let's try to submit it. It is submitting absolutely fine. So what could be the time and space complexity? So the time complexity is big O of n, as we are using a for loop, correct? And for putting into the hash map or checking whether we contains a complement, it is constant only. So the time complexity is big O of n because of traversing the array from 0 to n. And what is the space complexity? Just think about a scenario. If we don't find two elements whose sum is equals to target, then we'll be adding each and every element from 0 to n index n minus 1 index into the map. We will put it into the map. So in worst case, the space complexity is big O of n. Hence, time and space complexity both are big O of n. That's it. Signing off. Bye bye.